Hello and welcome to this Unity tutorial on simple patrolling enemy controllers. We are going to program the controllers for these snakes, and we're going to use additional raycasts to the grounding rays that we already implemented last video to detect if they hit a ledge, so the end of a platform, and if they do, they will change direction and go back. Let's start with a quick look at the enemy game object setup. We have the snake enemy object here that has a sprite renderer with the snake sprite attached, a rigid body 2D because we also want to use rigid body based movement, of course, for the snake enemy, where I froze the rotation so it doesn't flip around weirdly when it collides with the player or other objects, and a polygon collider that I fitted so it has some diagonal edges at the bottom again, so we don't get stuck on any box colliders. I also made it into a prefab because we probably want to have multiple enemies running around the scene. And then we make a new script, so create C# script and call that enemy controller 2D. This will be where our movement logic is attached. Here we need a lot of similar functionality to the platformer controller 2D. So I will simply go ahead and copy from the platformer controller all the logic over, and then we remove the parts that we don't need. That would be the input and the jump force. Our enemies are not gonna be jumping, and we don't need any of this in the update function. We're gonna write a new custom update function that does the enemy behavior. The grounding calculations we still need, as well as our speed and of course our rigid body. And you can already see there's a lot of common logic between the platformer controller and the enemy controller. And in a next video, we're gonna look at how to abstract that so we can save some redundant code. But this is not the topic for this video. Here we just see how to implement the simple moving back and forth on the platform behavior for the enemy. For this, we will create a new private field of type integer that I call direction and set to 1. And the direction is going to be simply the movement direction that we move in based on the testing of the surroundings. If we hit a ledge, we would invert the direction, and if we are not grounded, the direction would be 0, or we don't move. So in our update method, we would first get the velocity vector from the rigid body 2D, so we can modify it. Then we set the x value of the velocity to our direction multiplied by our speed, and then apply it back. So we just keep whatever vertical velocity we have. We don't modify that because we don't have any jumping behavior. And the horizontal velocity is going to be dictated by our movement direction. Of course, we also have to update our grounding here. So let's just call the update grounding method, and then we have to update the direction. And this I will also put into a separate method, just to make sure we don't clutter our update method too much. Make the new method here, update direction. And here we do the calculations that we need in order to find out in which direction we should move. First, we know that if we are not grounded, we don't want to move. So we would simply set direction to 0. Now we can also return 0 to just step out of the function right away because we don't need to do any other calculations. I have a return type here, but it's not assigned to anything, and that is a matter of taste. I like to have an optional return type in case I want to use it at some point, but of course you could make this a void method as well, and then simply return nothing to step out. Okay, So now we have already the logic for being grounded, and then we don't move. So if direction is 0, our velocity on the x-axis would be 0, and we would simply wait to fall down until we hit some grounding and then start to move. The first case we have to consider here is if we were not grounded, so we're falling down, our speed would be 0, and then we hit ground, and we have to set a default movement direction. That would be if our direction would be 0, but now we are grounded, so the first case doesn't apply. We should set direction to 1, just so we are moving by default to the right. Next case would be if we step over a ledge. So if the enemy would move sort of here to the edge of the platform, we want to turn around. Right? So we have to test if this is the case, and we do that by shooting a ray the same as we do for the grounding, just far to the left of the character down, and then of course one to the right to see if we hit a ledge there. And if that's the case, we would simply change the direction accordingly. This will look very similar to the grounding testing. First, we need the starting point of our raycast. It is the vector 3. We call that the ledge ray start left. And that would be our transform position added with a little bit of offset upwards. So we have a bit of margin to not accidentally miss out on a platform because the ray would start inside it. We can use the ground ray length also for the ledge testing. And then we offset that to the left with ledge test left offset. So we do a custom left and right position here to be able to position the rays perfectly where we want them and not depend on the sprite exactly being in the middle of the game object. And let's do the same for right. So just copy the line and do the right position as well. Quick hint here, if you have an error, if you hit Control and dot, you can open a quick fix menu. For example, here it will tell me to generate the field. Okay, I will just do the quick fix. Although the field is gonna be of type vector 3 by default because Visual Studio doesn't interpret the line correctly. So this of course should be floats. But it's kind of handy and saves you a bit of typing. And also we would want these to be publics, right? So we can set a value in the inspector. Then the raycasts are going to be exactly the same as the grounding ray, so we can just copy these lines here over. But let's go over them one more time to understand what is happening. We do a raycast to the left that starts at this ledge ray start, which is offset a little bit to the left from the bottom of our game object. We're gonna cast the ray downwards for this length, which is just the offset upwards that we set here, right? And then the same amount downwards, so we test actually below the object, and we're gonna test against the ground layers only, so we don't include ourselves into the ray casting calculations. And the same for the right ray. With the raycast in place, we can then include our direction logic. For the grounding, we tested if we hit something, because we're grounded when we hit something with our raycasts. The direction logic is actually just the exact opposites. We want to see if we don't hit anything. So if we actually step on a ledge and the raycast doesn't detect anything. So if hit left, collider would be null. then we would change the direction. So if the left collider is null, we want to move to the right. And if the right collider, so the right raycast, doesn't detect anything, then we want to move to the left. That should of course be hit right.collider. And lastly, it always helps to visualize raycasting so you know what kind of calculations are actually being done. For this, we will draw some more debug lines. So we call the debug draw line function. We would start at the ray start and end at the ray start plus the vector 3 downwards direction multiplied by ground ray length multiplied by 2. And this time I want to give it a blue color, just to distinguish between the grounding rays and the edge detection rays. Okay, same thing for the right direction, and there we go. Now we have directional logic. Just spotted this little error here. This of course should be vector 3 right. Let's now try out if everything works. We're going to do that by modifying the instance of the snake enemy prefab in the scene actually, instead of making the settings on the prefab directly, because we have to find good values for the different raycasting settings, and we can only do that in play mode, and that cannot be done on the prefab. So after we find good settings, we're simply going to apply our changes that we made to the prefab instance by using overrides. So let's apply the script, which we actually have to put in the end of the component list because you can't change the order of components on prefab instances. It's something that simply doesn't work. Then we're going to apply the ground layers and make sure that our enemy is not on the same layer as the ground layers, so our raycasts don't get confused. And I already made an enemy layer that I'm going to apply here to the snake enemy. Okay, and now I can hit play. I'm not going to put anything in for speed, so we are stationary. And here we can see we have the red rays for the grounding and the blue ray here for the ledge testing. And our ground ray spread should be a bit higher, maybe like 0.4. So this looks good. And then the left and right ledge testing. Let's see, this should be maybe something like 0.5, and the right one could be 0.45, sort of like this. Okay, now unfortunately this doesn't get saved when I exit play mode, so I just have to remember 0.5, 0.5, 0.45. Well, this was 0.4. And now I can apply these changes by clicking overrides, and you can see, oh, there is the new script. So Unity recognizes that the prefab instance has been changed to what the prefab says it should look like. But if I hit apply all, now my snake prefab is updated. And if I go and add a new snake in the scene, you can see that my new snake also has the script attached and all our settings saved. Now all we have to do is set speed, and I will do that in the prefab edit mode, so I can put something into the speed value. Okay, that looks good. Hit play and see if our snakes move back and forth, and there we go. Now they detect the edges and they turn around when they hit one. Done by our ledge testing raycasts. I hope you can now also easily imagine how you could extend this logic to, for example, detect walls if you shoot raycasts to the left and right to turn around when you hit a wall. In the next video, we're now going to look at how to animate the snake and how to get rid of some of this redundant code in the controllers, because the character controller for our platformer and for our snakes, they share quite a bit of code.